Operation and maintenance of a settled sewerage scheme is obviously extremely important, and the Sewerage Authority first of all has to ensure that no illegal connections are made to the sewer, as these would normally be of unsettled sewerage and that they would lead to rapid blockage of the settled sewer. Secondly, the Sewerage Authority has to assume responsibility for desludging the septic tanks, the interceptor tanks, as the householders can't be relied on to do this on time, and the Sewerage Authority can recover their costs through the monthly or quarterly water and wastewater bill. And thirdly, the Sewerage Authority has to regularly maintain any lift stations which might be used in the main sewer sections. This slide shows septic tank effluent discharging into a street gutter. This was taken in Greece in 1978 and is clearly an unsatisfactory situation. This shows something very similar, a poor flush toilet effluent discharging to an open drain in Kolkata, and this was taken just a few years later in the early 1980s. This slide shows again the basic components of a settled sewerage scheme. A house or a group of houses discharge their wastewater into an interceptor tank, and the solids-free effluent from the tank is discharged into the settled sewer in the street. Settled sewerage schemes were quite widely used in Australia, particularly in the state of South Australia, where they're known as septic tank effluent drainage schemes. PVC pipes are now very commonly used, simply because they're easy to lay and joint. And instead of expensive manholes, we use very simple inspection points, and we don't have to have an inspection point at every junction between one sewer and another. So costs are reduced. And this slide shows the roadside view of the top of an inspection point, where access is available to the sewer for rodding out blockages. This slide shows a situation which can be expected to occur during the night in a section of the sewer which normally flows under pressure flow. There is just some wastewater in that section of the sewer overnight, but that doesn't matter because there are no solids in the wastewater which will settle out because they've all been removed in the interceptor tank. So this is basically no problem. And then when people get up in the morning and start flushing toilets and using water discharging from sinks and showers, the wastewater which has been sitting in the sewer overnight will be moved down along the sewer. This slide shows a major problem with the interceptor tank in the centre. Wastewater is going to flow from the sewer into that interceptor tank because the level of the invert of its outlet is below the hydraulic grade line. This problem should have been solved at the design stage, either by increasing the depth to which the sewer under pressure flow is laid or by increasing its diameter. The latter option is shown here, and this also shows another very important point with settled sewers. The wastewater flows on the slide from right to left, starting off in a small diameter sewer, going to a larger diameter sewer in the section under pressure flow, and then back into a small diameter sewer again. So we go from small diameter to larger diameter back to small diameter. And this is possible with settled sewerage, but not with other sewerage systems such as conventional sewerage. This slide shows a typical lift station used with settled sewerage schemes. They're not very often required, only really in very, very flat areas. But because the wastewater flowing in the settled sewer does not contain any solids, it's possible to use a water pump rather than the much more expensive sewage pump. This slide shows the sanitation block in New Busa, Nigeria. And this slide shows the laundry facility in that block. And this slide on the left shows the lane side view of the sanitation block in New Busa. And the red arrow shows the sewer connecting the sanitation block to the lane sewer which runs in the centre of the lane. On the right is a new housing estate in Wisconsin in the United States, where settled sewers were put in simply because the capital cost of the septic tanks and the settled sewers was about 60% of that of conventional sewerage, so much cheaper. And clearly it would be even cheaper still in areas which had existing septic tanks. This slide shows a commercial system in the United States, and depending upon the elevations, it may be necessary to pump the septic tank effluent into the sewer. And this slide shows a settled sewerage scheme in the Nile Delta in Egypt, in the village of El Mofti El Kobra, in the governorate of Kafr el Sheikh, and this village has a population of about 3,000 people. In the picture on the left, you can see the cover slab of one of the interceptor tanks in front of a house, and the picture on the right shows an inspection point in one of the sewers running through the village.